Hello, everyone. Good late morning. We're launching this. We'll have a good conference. So we started a random introduction, and basically the topic of today is computer vision applications in enterprise. We have a range of audience from more focused on development, R&D, research, up to industry leaders, startup founders. So it's going to be a very good discussion. So with that, I'll start myself. I'm a director of AI for Stanley and Datar on the industrial side, mostly in B2B. I oversee a wide range of applications from manufacturing to automotive, robotics, quality inspection, etc. Also advise on some few other e-commerce applications. Generally, it's a big team and I'm more focused on maybe on the strategic side. But I've been involved with computer vision applications for maybe 10 years, from Robocop to crack detections of weapons, etc. And I've been also working with various annotation platforms because it's a big piece of the industry for error analytics, and we cover that as well. So that's my short introduction.
I'll go next. My name is Hyun Kim, co-founder and CEO of Superb AI. And Superb AI's mission is to democratize AI and also lower the entrance barrier into the AI technology. And what we do is, for the past 5 years, we've built a platform for labeling and managing computer vision training business. So we work with images, videos, LiDAR, geospatial, medical, and so on. And within our platform, we help our companies, our clients, label, manage data, and also QA, QC training data, and also curate data, and also train models. And a big piece to our platform is actually automation. So we like to semi-automate a lot of these pieces, so semi-automate data labeling, data QA, data curation, model training as well. Yeah, thanks.
Hey everyone, good morning. This is Pranay, Chandur, and I'm part of Walmart e-commerce, and I'm heading some of the data science divisions at Walmart right now, predominantly focusing on supply chain and fulfillment. So some of the areas I cover today are delivery quality, delivery promise, and overall customer experience, which includes pre-sales and post-sales. Yeah, so that's about my background, and yeah.
Good morning, everyone. Rahul, Singhal. I'm the Chief Product Officer for Innodata. Innodata is a Nasdaq-traded leading AI/ML data engineering company. We cover the gamut of collecting data from all modalities, including image, video, speech, text. We annotate data. We have platforms for text annotation, image annotation, as well as we have data scientists on the team who are building models and deploying models across different use cases in manufacturing, healthcare, and banks. My journey started 10 years ago in AI. I led the Watson platform for vision, speech, and NLP, and then I ended up at Innodata. Thank you.
Hi. Hi, I'm Sumedh. I'm a computer vision researcher. I have close to 8 years of work experience in the computer vision space. I started out working on classical computer vision even when deep learning was not that famous, and then transitioned towards deep learning. I primarily work at the intersection of product engineering and research. Apart from that, I worked in domains of retail, healthcare, and education space. Worked a lot on training models with various data, deploying, building the proper product around it, and then making sure whoever uses it, they have a very good customer experience. So kind of today I'll be covering a little bit on the experimenting part of models, and a little bit on research, and then final deployment and productionizing deep learning models.
Thank you for the intro. So I'll start with the question that is posed to me from the panel from previous discussion, which is, let's talk about the use cases. What are the most common areas for the use cases, and what are the most effective use cases to follow? So based on, again, decade of experience, I summarize it this way, and again, this is my personal take, it's not like a representation of any company, we had that discussion as well. I guess it goes for the whole board, I guess, let's say. It's basically finding the needle in the haystack. because that's generally a very tedious work. People cannot even do it. Those are the ones that I'm much more interested in. In manufacturing, it boils down to the quality and sort of audit. And then among those, you usually go after the ones that the cost of defect or bad stuff is the highest. So I had a use case for inspection of the X-rays of industrial welding for, let's say, pipelines that get buried the next 20 years or so. So any small air gap or any issue in the weld would cause public panic and many other issues environmental. And these people who are inspecting this, obviously they do their best, but generally inspecting very irregular pattern in X-ray is very difficult. It's the boundary of human vision. That's another thing. Our eyes is not designed to process that spectrum of color. And more than that, we wanted to do a very quick audit about like the whole historical side of the project. And then as we brought in the AI, we learned a lot more about how to train people. So use cases like this are the most effective one for an organization to follow. And I'll leave it at that. Also,
just to add to your point, also in the use cases, especially since I have some experience in the healthcare space, maybe I was working on some cancer-based detections. So sometimes people are scared to like go for a biopsy. Sometimes we can depends the area to know as to whether you have the abnormality or not. Computer vision actually plays a very good role there. Computer vision actually plays a very good role there. You actually capture the image of the region of abnormality, and then you can feed it to the model, and then the model actually tells if it's really good. Kind of it's a preliminary analysis rather than going through a very painful biopsy process. So this is one of the use cases as well.
So how about this one? We go over the question, but include the answer to this one, your questions, right? So I'm going to ask you about, what is the most effective way to be successful in the project? And please feel free to add your favorite use case to that story. How's that? This is a question for you.
So most effective.
What are the challenges that you encounter?
So
add to that. What was your interesting case?
Yeah. So as a company that helps other companies basically build machine learning models and ship to production more efficiently, we're at a position where we can see what are some common challenges that companies are having across industries. I think I can bucket those challenges into two groups. One would be for more nascent teams that are just starting their machine learning projects. For those, I see that data labeling and data quality control is the biggest issue. They want to catch both, data accuracy and also throughput in terms of building or labeling the data. And always there are things like human errors you need to catch, like edge cases or nebulous guidelines. Those are always challenges. And also for QA QCing, the most naive way to QA your data would be manually review every single image or label, and that's not very efficient. So as a company, we try to solve that issue using automation. And the second bucket would be for more mature teams that already have well-trained machine learning models, maybe already into production. For those companies, what they want to do is they basically want to improve their model accuracy, say from like 95% to like 98%. Right? They're looking for that last mile, and the challenge there is data curation. So let's say you're a self-driving AV company, you already have billions of images of cars. How can you be sure that you have every single type of car in the world, right? It's not. I'm not just talking about like trucks and sedans or buses. You have to be sure that you already have enough instances of like cars with trunks open or doors open, or like rainy day or snow day, all of those cases. So it's important to analyze the distribution of your data, not just the class distribution, but within the class distribution as well, in order to improve your model accuracy to the extreme. Okay? So that's some of the challenges that I've seen. And the second part of your question was,
add your favorite use case. If you're not disclosing any customer information.
Not disclosing any customer, but interesting thing that I've seen is so we've been around for 5 years. The first year and two, we mostly worked with like high-tech IT industries like self-driving and so on. But more recently, we've been seeing very rapid adoption of machine learning tech within more traditional industries like agriculture, manufacturing, logistics, so on and so forth. So, yeah, I'll end with that.
That's not the easiest start, I would say. He didn't start from easy cases. So the next goes for Rahul. What enables a successful computer vision project, and what do you find it to be sort of like the critical key for the entire process?
Yeah, so we have seen across industries tons of very interesting use cases. So I'll start with manufacturing. We're working with a lot of visual inspection use cases, where an example is a large aluminum manufacturer has 100 mills and they're looking to do anomaly detection on a defect that comes in. So it's a fairly interesting use case, and we're seeing those kinds of manufacturing use cases where anomaly detection and visual inspection use cases being asked by lots of manufacturing companies. We're seeing it in content moderation, so lots of social media companies, lots of e-tailers. They have data is exploding and images and videos are exploding. How do you manage your brand identity? So brand safety, we're using image and video classification models around terms of use are some very, very dominant use cases that are actually getting very high level of accuracy. In medical, we're seeing more of lab data, so and radiology images, where we're looking to classify different melanomas. We're looking to classify. We're doing object detection and classification use cases in healthcare. So those are some, but every day we see more enterprises spending and looking at a variety of different use cases. It could be around object detection.
So how to be successful? Like, did we cover that?
Yeah, so the most successful tends to be around content moderation use cases, are where you're getting fairly high level of accuracy, I think, with humans in the loop.
Success level to Sumedh. So explainability is a big topic, right? The AI tells us, this is a defect or this is a cat, but we actually don't know if we should trust it and push it for production. Can you go over the explainability topic for us and why it's so important?
So let's take a step back. So generally when you train a computer vision model, you're dealing with a use case where sometimes you have a lot of data, or you may not have data, you might have very little data. So you go with like a pre-trained model, you do something like transfer learning, and then you have for your set of images that you didn't train on, it's working well. So with your offline data set, it's working well. We're very happy, build a product around it, and then you deploy it into production. And then suddenly in production, the game is totally different. The kind of data that you're getting is different, and then the results kind of move in different areas. So how do you kind of explain as to why was it successful in your lab, and then suddenly when you went into production, it's failing? What's going on? Probably people who do not have a background in machine learning, generally people who are in the business or the stakeholders, you need to kind of explain it to them in a certain way. It's very hard to explain why deep learning model predictions are like in a certain, like the decisions are in a certain way unless you really know the theory behind the neural networks. So there are, so in these situations you need to explain it so that people get convinced. So how do you do that? So there are frameworks like GradCam, Line, SHAP, wherein you just feed the image through the model that you have trained on, and then it will kind of give you like a heat map as to in which part of the image is the maximum concentration. Kind of you know that okay, the neural network is learning in this particular part of the image, and that is how it is describing the class of that image, right? So this way it's very easy for someone to interpret as to like, okay, this is that means okay, the network is learning, it's not just giving like random results, right? That is one thing. And the second thing is sometimes the probability values also, like once the final output spits out a confidence value, which is like a probability, then if it's really low, then you can be like, hey, I think even the model is not really confident, but when you design a production system, it also depends on the decision making. So that way, you can build some kind of explainable AI framework by using these simple techniques so that general folks or people who are not really familiar with machine learning can also understand and then kind of support you in the process that, okay, I think with data, and once they see that, okay, it was wrong, and then the heat map was at some different place, train the model again, and then it gets better. So kind of people understand that, and then they support you moving forward. So, yeah.
Thank you. That short intro to Pranay, what do you see the most exciting current use cases of computer vision, and how do you think that will impact the industry?
So, first of all, being a data enthusiast, the way computer vision or the AI applications that we have today, it's really fascinating. It's helping our industries like across all the domains. So let's start off with the most critical piece, at least for me, which is healthcare. So, like Sumedh mentioned, detecting the cancer, like various types of cancer in its earlier stages using computer vision, and some of the areas where like we all have experienced with COVID. So we're at some point of time we ran out of COVID tests, so we used X-rays and scanning for us to detect how critical how impactful it is, and how critical it is for a particular person. So we utilized computer vision and AI for us to deal with tumors, cancers, or diseases like COVID. So very fascinating. Coming to agriculture, like we have seen a lot of shortage in the resources recently in agriculture, and due to that, like the way we are using computer vision, especially in the areas like harvesting or understanding what kind of pests are actually destroying the crop, and like productivity, the yield assessment or yield management. So there are a lot of areas, even agriculturists started picking up computer vision, so it's really interesting and fascinating, which is also essential for us to survive. Third one is transportation. So transportation is my favorite, like the way we have autopilots, my favorite Teslas, like the way they are handling it, and the way it's well integrated. You have sensors, and you have your image, like computer vision sitting on top of it, and the way it's automated. So it's really fascinating for us to the way it's adopting AI, and it's not just the way I look at it is it depends on the person. So we use AI for luxury like autopilot, but we are also talking about some of the use case like our cab services like Uber or Lyft. They are also, because of the shortage of resources, they're saying they need someone who can actually automate and make a self-driving car. So which is not just about luxury but also a necessity at this point of time. So last but not the least, we'll talk about retail. So coming to retail, so whether it could be e-commerce or in the stores, like on the e-commerce front, we have a lot of like giant fulfillment centers or distribution centers where you have to pick, pack, and ship millions of products in a day. So yeah, we have a lot of resources for us to better do it, but at this scale we need systems to assist these resources. So that's where computer vision or AI comes into place for scanning, for providing the right recommendations of the kind of boxes that you need, or like providing recommendations around the dimensions of the products that based on what kind of boxes that you like to put in, and some of the areas like in stocks, like the product availability, to make sure we have items in stock for our customers. So overall, so it's the way I look at computer vision or AI, like one of our attendees was mentioned yesterday from Johnson & Johnson. So the way I look at it is not a threat to jobs or something, but it's more of a way to assist the existing resources that we have, and which will, end of the day, improve a better customer experience and increase our productivity and the quality of the outcome that we are providing to customers. So that's how I look at it. So that's really fascinating. The way it's assisting and supporting our existing products. That's the fascinating part to me. I would like to also add one more point to the challenges, and I would like to add on to what you mentioned on the challenges, and also some of the use cases around, like, how we're using here at e-commerce. So the challenging part, especially in my experience for computer vision, is two areas that I have seen. First is data tagging or data labeling, and the second one is data quality, like the QC. So, as I said earlier, it should be a strong collaboration. So, if you build a model or application on computer vision, it's gonna not run silo. It should be a good collaboration and integration between, like, your operations, your product, your account management, so and also data scientists. So it should be a cross collaboration. That's the only way you can evolve.
I agree with that. Yeah, and I'm hoping you're covering that. Huh?
Yeah, but it's so much easier said than done, right?
Oh, of course. It's a whole platform ecosystem. Yeah. I don't know if you want to add to it, but basically the experiences that I have is the data scientists need to pretty much use the same platform that the end user is using to kind of like get the result for error analytics or re-annotation, and then they need to really speak the same language. That's another thing we ran into, that everything has its own jargon, right? The industry experts or the users know, but the computer scientist doesn't know when he starts annotating the data. And then the whole taxonomy of annotation is a huge deal. Yeah, as you said, yes, something more to be done. But overall, so you started, like, you covered a lot of fronts about the future. Self-driving car is a big piece of it. You started your company covering those use cases. The question is, obviously, we are not really fully there comfortably. So what are some of the obstacles from technical side to productionize these models that you see? I can start with Sumedh very quickly. What do you see that blocks the thing that is working perfectly in the lab to go work perfectly in the real world?
Yeah, so what I've really noticed is, I think, the research part on defining the model architecture. I think that is kind of a solved problem. Of course, you can use slightly better models, which slightly gives you an edge in accuracy, but kind of use one of the very good pre-trained models, residual-based models, etc., you're going to get very good results. Now, from there, you build the entire product and you ship it into production, and then people are very excited, and then next thing is, like, you want to scale it, right? So when you want to scale it, how do you want to scale it? Like, what your business is looking at. So especially in the computer vision space, the type of camera that you use or the visual sensors that you use to train your model, it should be very similar when you deploy it in production, and then when you're, like, getting those images back, right? So if you're just providing model as a service to solve a problem for customers, then the customers must make sure that they use cameras which is very cameras or acquisition devices which is very similar to what your model can accept. That is one thing that's important. Then the second thing is the speed and accuracy also is very important. Depends on the use cases as well. And then, like, the next big thing is, like, the scaling part of it. Like, say if it's some kind of a recommendation engine or time series kind of a problem, your data is kind of already annotated or audited, but in computer vision, kind of needs someone to go through the images and to check it till you're very confident about your model. So there'll be like a lag that time before you can actually get your metrics about the model performance. And how do you handle situations like this? And then also situations like speed and the kind of hardware that you would like to use. Again, this is very important. And in general, the hot topic everybody is discussing today is like the MLOps part of it, right? Basically, how do you scale the same model across different products, and then how you can still make sure you provide the same experience and value that you provided for that one product that you deployed it in production. Like say, for example, when it comes to like autonomous cars, like that one car that they show which moves around really great, but the same thing you have to do it like say for like 1,000 cars in 1,000 locations. The terrain is different in different areas, but still you need to provide the same experience to the user. So like these are certain things that we need to consider when you're actually building a very scalable computer vision based solution.
So what do you think about this?
So I think Sumedh already touched upon it, but to add to that, I think the biggest challenge to productizing ML models from lab to actual environment would be basically closing the loop between model data collection, labeling, model training, deployment, and then back to data collection and labeling. So that cycle has to repeat, and I'm sure you've all heard of things like data drift, data shift, distribution shifts. So the types of data that you gather during development phase, the training data and the test data, it's got to be different from the distribution. It's going to be different from what your model is going to face after production. So it's very important that you keep track of what kind of real world data the model is facing after production and keep iterating and retraining your models over and over again.
So then, let's say you have a platform that is going to have a lot of different use cases, and it's automating some of the work. Like you literally are dealing with an even more complex problem that the companies that are only focused on the use case A and one. Are you running into this, like thinking in terms of like a roadmap of a product?
Yeah, so definitely have that closing the loop in mind, but also it's a big challenge, and it's a challenge that's big enough that it's not going to be possible for one single company to solve. I think it has to be handled as the whole ecosystem together. So there are a bunch of ML ops, data ops, startups and companies out there. For example, we focus on the data side. There are companies that focus on the models or the infrastructure, and we all basically have to work together to integrate our products and deliver a cohesive product set. Yeah.
Rahul, what is your experience with this work?
Yeah, I think we touched on a lot of these, but I would say in our experience, data quality is the most important thing. So, and especially when you think of image and videos, right? You start looking at you have your test data or your ground truth data, and you have your testing data. That needs to be very diverse. And take a camera, right? If you're looking at camera images, you have varieties of different cameras with varieties of different pixels and pretty much innumerable number of scenarios, whether you have to have black and white images, you could be having color images, you could be having dispersive light, you could be having half images. If you're doing an object detection model, if you don't consider all of those scenarios, your models are going to fail. And then you need a platform that is able to do error exception and being able to throw out those errors out so that you have a human in the loop as well as continuous learning happening. So when you think about the productionizing these applications, I look at it as three things. First is data. What is your data strategy? Do you have the right enough amount of data collected with diversity included in it, variety included in it? Do you have right ground truth data as well as testing data? Do you have the right data pipeline built in, which is your infrastructure side of it? I think Sumedh talked about all the infrastructure side becomes really important. It's just not about data, but then do you have the right cameras? Do you have the right, are you doing an edge deployment? How are you going to ensure that the latency is sub-nanosecond when you're trying to drive a model? So are you going to do an edge deployment? And if you're doing an edge deployment, how are you going to ensure that that there is continuous learning going to happen and it doesn't become extremely expensive, right? Because we have a client who was sending data through cell phones, millions of images, and that he ran out of budget, right? So how are you thinking about the infrastructure side of it, which is your ML ops, and then the productionizing of it, and then how is humans in the loop considered?
So here's a scenario I run into a lot. I have my own clients, right? So how many images should I give you? And then when you say good quality, how do you measure good quality, right? To Sumedh point, also when projects start, you buy the best computers, best edge devices, best computers, and actually provide the best quality images. But as the project goes on, you realize reality is not like that. You have poor lighting, you go for cheaper cameras, all of a sudden you want to reduce the cost of your edge, reduce your compute power, etc. So what are the KPIs that when people come to you guys and say how many images is the minimum that I need, and then how do you go back to them very quickly and say the quality of this data is only getting you to 85% at best based on an estimate? Have you run into that sort of pipeline of assessing different opportunities presented to you?
I can take that, please. So, yeah, that's definitely a good question, and it's a challenge in pretty much not just computer vision, but any data science project that you think of. So, what always worked me, my experience is basically, so yeah, we will be stepping in. So you might have knowledge on how you can build a model, but since we are evolving on a daily basis, it's all about having a framework where you can start applying that in any new project that you're working on. So today you're working on what do you call it, non-compliant project, and tomorrow you might be working on a project where you have to improve your sales. So the kind of problems you're solving are very different. But the way it worked for me is to have a playbook. When I say playbook, basically it's not the playbook on how you can build a model and what the stack that you have to use, but a playbook where you have all of your stakeholders involved as it. So let's say you're trying to take down offensive content on the website, example. So it's very tough for you to talk to your operations or your upstream teams on how you can get the data in terms of the number of images or the quality of the images. It's very tough. So we always started with giving input. Let's start off with what we have, then see the accuracy and see what the challenges we're solving, and then iterate on it, try to understand how much do we need, and then come up with a benchmark and then learn from there. But yeah, it's definitely something we don't have a precise answer or a process. It's all how you learn from it and evolve. So it's definitely an iteration, I would say.
And I think that while it's
the more is to say
cheap, right? You can find a lot of it. It's quite cheap. Some use cases, the data is not that cheap, but Rahul, you wanted to also.
Yeah, I think again, it's very hard to say whether you need 5 images or you need 1,000 images. Most of our clients start by saying, we tell our clients 500 images. Just let's start with 500 images, let's annotate those images, let's look at the accuracy of the images, and then the most important aspect is diversity, right? And is the diversity is, we tend to say, we in our experience, you want to have different scenarios captured, and we say at least see that scenario at least 50 times. So you have to have an image at a scenario level 50 times. In text annotation, we tend to say every data point that you're trying to extract, we would say 30 documents of different varieties should be seen by. So those are some rules that we have seen work, but it's much harder in image and computer vision.
And then the second question is always the scoping. So what is the team size, or how long it would take in your organization to come up with a good MVP?
Depends on the use case.
It's a sad question.
Resources. Do we have a budget?
Dark days. This is your boss coming to you randomly and asks you, hey, we need an algorithm.
So I think simple use cases around just classification use cases, you could deploy something, like we did something for stain detection, right? We're trying to detect stains on a cloth. It took us 3 months, or end-to-end, where it was 7 different types of stains, and then we were detecting those stains, and we were building an object detection model around it, or object classification model around it. 3 months later, we are working on the visual inspection where there are 154 defects. That's like a 3-year program. So I just think it depends on the complexity of the project and how does it then integrate into production.
And that's what I'm probing for. How do we measure complexity of cat detection, which a lot of transport planning models bring that, to like a lesion of cancer detection, which, good luck getting enough data of this. And then at the same time, they're like, I heard it from various vendors that, yeah, you can count like screwdrivers or this and that. But then if the camera is on top and you want to count pineapples, that's apparently a very difficult problem.
Yeah, and I think it also depends on cancer detection. You have to be 99.99% sure you can't. So there, obviously, it will take you like years and years to do it. So we're working on glaucoma detection, right? So in ophthalmology, those are that's a 1-year project with 100,000 different glaucoma images. It's still not there, right? Yeah. But stain detection, yeah. I mean, if you identify a wrong stain, the impact is not as much, right? So I think the criticality of the use case drives the timeline.
So
one thing to add, there are also industry-specific nuances, depending on what kind of infrastructure your model is going to be deployed on. For example, if you're deploying on an edge device, your model has to be very lightweight, which means you don't have very much computing power, which means you'll have to use a lighter weight model. That means you'll need more data to train that more accurately, right? And that's also the case for things like self-driving. If you're deploying those models within the cars, you have to run it in real time, sub-millisecond inference time. That means your model has to be lightweight, and that adds another layer of difficulty.
So if I may, this is a big one, we only have 2 minutes, but this is not about Then the question is really about the future. If you want to let's say go for one sentence, 100 something character, what do you see the next sort of hype or hype cycle in building computer vision models that people are going to chase after? You see a boom in annotation platforms, right? There are many billion-dollar, not many, but there are billion-dollar companies right now. What is the next thing?
So I'm a bit of a skeptic, but I do see a lot of hype around synthetic data. So there are largely 2 schools of thought for synthetic data. So one would be using simulators, like gaming environment, to generate these data. The other one would be to just use a purely deep learning-based generative models to basically use models to generate fake images. I think there's a lot of hype, but there are a lot of potentials and opportunities there. So we are also, as a company, investing into that, but we'll see what happens to that technology. Right now, there are a lot of companies that are saying that synthetic images work, but there's also that challenge. It's called sim to real. Discrepancy between synthetic data versus real data. Does it really help your models? That's still a question to be answered.
Anybody takes 100 get down here? What do you think is the next?
I was going to say synthetic data. I'm going to take the opposite of you. I'm going to say
I
think it's huge. I think it's going to be it's going to drive fundamental change in more use cases being deployed because you will have the ability to have longer data. Because I think one of the hindrance has been collection of the data. Companies may have the data, but it happens to be customer data. You can't use that customer data to build models and monetize it, right? So synthetic data starts to play a very important role, and we are seeing, and we personally have invested in it and built synthetic data capability as a huge differentiator.
Yeah, we have very, very, very fun MC here. So, is there?
I do feel synthetic data because sometimes it's really hard to get real data, but if you can actually simulate it.
And please don't miss the Dolly 2 demo in the exhibit hall. How many people have played with that so far?
I did.
Yeah?
Boston Dynamics role, right?
No, the other two, the
image.
OpenAI,
Oh yeah, that was pretty good too.
Magic, definitely played it. It's pretty